Welcome to the video demonstration for Indoor Power Solar Robot. Let's first start by looking at the prototype that we have built for this project. As you can see here, the prototype actually has 40 amorphous silicon solar panels which are supposed to harvest the energy from indoor lighting, as can be seen on the ceiling. A closer look at the robot here shows the strip board circuit that we have made ourselves for the functionality, and the important components that we are going to be demonstrating today are placed right here. Firstly, there is the camera which takes images and serves as the eyes of the robot. Right next to it is the small chip which is actually a thermal sensor which measures the surface temperature of the objects in front of it. And here you have the fire extinguisher which is supposed to extinguish the fire when the thermal sensor detects a fire in front of it.
Yep. As you can see here, there are two phones. These two phones are actually an indicator for our system to be able to text, which is for this phone, and call, which is to this phone later on when a fire is detected. As you can see on this side, there's a XB, and this XB chip is connected to my laptop. There is also a modem which we are using to send SMS and call later on. On this side, you can see this is a user interface. There is a camera vision here, which is currently what the robot is seeing, and there's a thermal vision here, which is what the temperature that the thermal sensor is detecting now. So in this room, the temperature is roughly 22 degrees Celsius to around 24 degrees Celsius in this panel. You can see here, this is a log table, so showing what is actually happening. There are heat map receive, and there's also syncing with the camera as well.
For the purpose of this demonstration, we are actually going to be lighting a small lighter in front of the thermal sensor instead of a wildfire, just for safety reasons. As soon as the fire was detected, an SMS was also sent to the owner of the warehouse, and a call was made to the relevant authorities. As you can see here, the base station was actually able to capture the images that were seen by the robot as well as the thermal readings. However, the user does not need to be primarily at the source of the incident itself to see this. We have created a server which connects to a distant location, and through this server the user can actually be sitting at home and still be seeing the log of what is observed by the robot. As you can see in this image here, the log was actually able to show the fire that was seen by the eye of the robot as well as the thermal sensor readings. To demonstrate the charging of the batteries using the solar panels, I have actually connected an ammeter to measure the current flowing into the batteries. And as you can see, under current illumination conditions, the battery is receiving around 11.2 milliamperes from the solar panels. I have also connected a voltmeter to measure the voltage across the battery level, and as you can see, the voltage across the battery is increasing, which indicates constant charging of the battery using the solar panels.